I've just received my copy of James Maxlow's new book, Plate Tectonics. I thought I'd do a video review of it, and the easiest way to do that, read out various bits from the book, I think. It's Plate Tectonics, a paradigm shift in thinking by Dr. James Maxlow. And of course he's a PhD in what he's actually discussing here. Oh, and this particular book, it's by Academia Press in Washington, and unfortunately that makes it quite an expensive book to buy. So you might need to try and get a copy from a good university library or places like that. Start off, we've got a section about the author. So he tells us that during his research years, James met and communicated with many wonderful scientists from around the world, most notable of which was the late Professor Samuel Warren Carey from Tasmania, the father of modern tectonics, Jan Kozivier from Poland, who was the first scientist to measure and calculate an ancient Earth radius using modern seafloor mapping, and the late Klaus Vogel from Germany, the father of modern small Earth modelling studies. It was during James's studies that Professor Carey recognised the potential of his research into tectonics. Carey then kindly passed on his baton to James in order to further his ongoing research into tectonics. James gained his Master of Science in Geology in 1995, followed by a Doctor of Philosophy in 2002 in Perth, Western Australia, including a letter of commendation from the University Chancellor for original thought-provoking research. So if we have a look at the preface, let's just introduce the idea. It's got an interesting section here about the limitations of plate theory. This is the conventional plate tectonic theory. Ongoing, generally unrecognised or even acknowledged limitations to continental drift-based plate tectonic theory include, but are not limited to: over the past 60 years, plate tectonics have continued to be presented as a conceptual framework, using idealized cartoon sketches to portray plate assemblies and basic mechanisms. To date, this framework has worked well, and scientists and non-scientists alike readily relate to these sketches to visualize plate motion, subduction and mountain formation over time. But an argument will be made that plate tectonics haven't gone beyond this conceptual phase, and as a consequence these conceptual sketches have very little to no relevance to the sciences or industries today, in particular the mining and exploration industries. And actually that's the industry that James was employed in as a geologist, so he would know quite a bit about that. Second one, plate tectonics is portrayed as a random process of fragmentation, collision, augmentation and dissipation of crustal plates across the Earth's surface over time, currently considered to be opening within the Atlantic Ocean and closing within the Pacific Ocean. Yet, modern geological mapping of the continents and oceans, in particular the Geological Map of the World, 1990, demonstrates conclusively that a random plate motion is not conducive to the seafloor geology shown on this map. It is now known that all oceans contain a mid-ocean ridge, and each plate is shown to be increasing their surface areas over time. This increase in plate surface area is symmetrical about the mid-ocean ridges identified with each ocean, and this cumulative surface area observation is not supported by continental drift theory. The maximum age of exposed seafloor volcanic crust, generally located within the continental margins, is early Jurassic in age. There are no observable instances where the age of the modern seafloor crust is older than 170 million years, whereas on a continental drift model there should be remnants of older seafloor crusts. While vast amounts of research monies go into assembling crustal plates back in time, assemblages are poorly constrained by geophysics and remain conceptual, in particular for Precambrian times. For each assemblage, there are often multiple plate fit options to contend with. For example, the selection of 11 published assemblages shown below. As a result, these meaningless assemblages cannot be used confidently by either science or industry to display global or even local observational data. And then he's actually got a small diagram here with the various assemblages that have been suggested for the for the ancient Earth at approximately 1,000 million years ago. So that's before certainly before even multicellular life originated on Earth. So since the mid-1960s, there have been a vast array of global observational data collected, in particular from each of the geosciences. Because plate tectonics only have a conceptual framework to work with, these data cannot be modelled globally, in particular for past geological times. As such, both science and industry are missing out on a vital platform to display historical data about past geology, geography, biogeography, climate, and so on. So he's basically outlined some of the problems with conventional plate tectonic theory. So in the contents we've got quite a few things. He's got the main paradigm shift in thinking, paradigm shift in plate modelling, and then he tells us all about he's got paradigm shift in paleomagnetics, a paradigm shift in space geotechnics, geological paradigm shift in paleoclimate, a paradigm shift in understanding extinction, right, so basically he's saying that this is a major revision of thinking. So let's right. So this is just basically so it's conventional wisdom, which is basically taking us through what plate tectonics actually thinks at the moment. And then he's go on to some new discoveries, just to take us through. So we've got the mapping of the seafloor, which is all basic plate tectonic stuff. of how the age of the seafloor is known, and the new ocean floor is being created. And these are all put down. These are all produced the geological map of the world, digitized with permission. So this shows the age of the ocean floor. The youngest is in the middle of the oceans here, and as we get to the continents, it gets older. And this map again is another map, just showing the similar idea with slightly different colour scheme. So we've got on to a paradigm shift in thinking, and here's all the ages of the ocean floor put on a globe of the world. This is another projection, and this one's actually showing where the new ocean floor is being created. You can see here in the Pacific and in the Atlantic, down in the southern oceans here as well. And this shows, I'm not too sure what that's showing. Right. So he goes on to explain how these maps are created. So he goes on to chapter 4 is a paradigm shift in plate modelling, and he actually quotes Professor Carey here. But in the end, the rigorous approach has paid off, for it has revealed a discrepancy which had not been apparent. It was not my method that was at fault, but my assumption that the Earth of Pangaea was the same size as the Earth of today. The assembly of Pangaea is not possible on the Earth of the present radius, but on a smaller globe. These difficulties vanish. James Maxlow actually takes us through his own reconstructions of a smaller globe and his various models. He describes how these models are constructed with rigorous how the rigour of the ages. So he actually says that they fit together with about 99% accuracy, or better than that, in fact, I think. These are the various shot views of the models from the South Pacific Ocean, and then the Indian Ocean, Caribbean Sea, Atlantic Ocean. And these are spherical small Earth models of the Jurassic to present day increasing radius Earth. Each small Earth model demonstrates that the seafloor crustal plate assemblage coincides fully with seafloor spreading and geological data and accounts, and accords with the derived ancient Earth radii. So, and then we've got another geological map of the world, and the Arctic Ocean. This is the view of a view from the Arctic Ocean, how that's actually evolved over time. Atlantic Ocean, Caribbean Sea, Indian Ocean, Pacific Ocean, South Pacific Ocean, and this is the Mediterranean Sea. South Asian and the Southern Ocean. So we then go on to the pre-Jurassic Earth, because James Maxlow has actually taken these modelling studies even further back in time to pre-Jurassic time. And he says that, again, he quotes Hugh Owen here, there is nothing more contentious in global tectonics at this time than the expanding Earth concept. And then he goes on to explain how Klaus Vogel constructed these models in the 1980s, but James actually been able to take it even further back in time. So this is going through the detail of how things are actually how things expand. And it goes on to the various constant Earth models and increasing Earth models here. We've got the detail there. So chapter 7 is modelling continental crusts. It is, and he actually quotes Klaus Vogel here, it is theoretically possible for all the continents without shells to fit together at approximately 40% of the present Earth radius, by considering that continental shells were formed after the continental crust had fragmented. So it more detail about the models and how they all fit together, I think. Various phases, and these explain the various phases. So chapter 8 is chapter 8. We're now on to ancient supercontinents. The fit of the continents on a smaller Earth appears to be too good to be due to coincidence and requires explaining. And that was from Keir, one of his quotes, and I've forgotten his first name. So anyway, ancient supercontinents were so these actually, this is what they actually looked like in pre-Jurassic times. So right back to the Ordovician, and then up to the Permian time. So that's about that's about over 250 million years ago, something like that. So the modern continents, and he quotes Klaus Vogel here. Terrestrial expansion brought about the splitting and gradual dispersion of continents as they moved radially outwards during geological time. And so we've basically got various reconstructions here over for Australia, and another one for Africa and Arabia, Antarctica, Europe, Russia, India, and Greenland, South America, and then he goes on what the future might actually entail. On to chapter 10, and he actually, the quote here is, "It is not a task of the geologists to explain problems beyond their discipline. Their task is to see and correctly explain all geological facts." So here's he's actually presented chapter 11. He's presented a proposed causal mechanism. This is actually the reason why the Earth is expanding at the present. And again, he's quoted Creer here. It may be fundamentally wrong to attempt to extrapolate the laws of physics as we know them today to times of the order of the age of the Earth and of the universe. But despite that, he's then gone on to explain that it is most likely reason that the Earth is expanding is something that has only recently been recognised since about 2000, when the European Space Agency sent up various satellites, and we realised that the Earth was being bombarded with various matter from the Sun, from the solar wind. So this is the plasma transfer from the Sun. And he says the near-Earth observations presented here are based on a suggestion put forward by Eichler in 2011. Eichler posited the question, does plasma from the Sun cause the Earth to increase in size? And by presenting a new argument based on known physical observations, he suggested that the answer to this question might indeed be the case. Eichler elaborated with his statement that to assume that the Earth is gaining matter and that this may be due to nuclear synthesis within the Earth seems to fly in the face of conventional wisdom. And it does, based on empirical evidence which strongly indicates that an increase in Earth's size is indeed valid. The task confronted is to formalize a viable mechanism whereby this occurs. In a plasma universe, the Earth is under constant bombardment from space, with all the necessary components to reconstitute matter from its component parts deep within the Earth, not requiring physical constructs which have never been experimentally observed. The Earth, having a magnetic field strong enough to interact with impinging particles, gathers more than sufficient fundamental particles, namely electrons and protons, to account for a slow increase in matter internally over hundreds of millions of years. There is therefore no lack of component particles to create new matter deep within the body of the Earth. The exact process by which this occurs is complex in nature and, like the interior of the Earth itself, involves speculation as to its dynamics. It is argued that the avenue of approach proposed here is plausible and warrants further serious scientific investigation. If new matter has been added to the interior of the Earth, there must be an answer to the riddle of the dynamics of the process. And then of course, James Maxlow actually goes on and explains what he thinks might well be happening to all these particles which are being added to the Earth. So in fact he's postulating the particles are so small they actually pass through most of the Earth, and they actually get to the core of the Earth, and so the core of the Earth actually expands, and on this one he's taken us further back in time, so he's showing how he thinks the process has changed over time with the expansion of the Earth. So chapter 12, a paradigm shift in paleomagnetics. The many geophysical and geological paradoxes that have accumulated during the past 2 or 3 decades are apparently the consequences of forcing observational data into an inadequate tectonic model. So this paleomagnetics, the ancient magnetic field of the Earth can actually be studied, and we have the various magnetics. So this is quite a detailed one about how the magnetic field of the Earth would be affected by the Earth expansion. Without any Earth expansion, we have apparent polar wander, which it is. So so James Maxlow explains that conventional apparent polar wander paths for North America, we can actually put those all together. So you can actually plot those all together, so all they all coincide together. So he explains the various polar magnetics. Right, and quite a detailed one. So eventually all the magnetics coincide to actually produce the give us the position of the north and the south poles, magnetic poles. And from that we know where the latitude is on the ancient Earth. So chapter 13, a paradigm shift in space geodetics. Proof of any theory comes through direct observation or by direct measurement. The in the expansion of the Earth at the present is being measured, but as James points out here, as he noted that in 1993, when this started, when they first used to establish a global geodetic network, the scientists involved noted that the root mean squared value of up-down variation in Earth radius motions of over 18 millimeters per year. In other words, the radius of the Earth was found to increase by up to 18 millimeters per year. So why haven't we heard anything about it? At that time, they considered that this up-down motion to be extremely large. They did not consider any increase in Earth radius when making this judgment, but instead compared it to the values that were expected. So it is significant that they expected that most VLBI stations will have up-down motions of only a few millimeters per year. And they went on to recommend that the vertical motion be restricted to 0, because they considered that this is closer to the true situation than an average motion of 18 millimeters per year. So he explains how they were faced with a daunting problem. So they basically took it out. They just ignored it. So we've now got, and again, if we actually put those motions back in again, it gives us various increasing radius settings. Okay. So chapter 14, geological implications. Why should a body which is expanding develop huge extensional basins with a very deep source? As testified by the earthquake foci pattern, while elsewhere very shallow extensional ridges with an associated shallow seismicity implies a great complexity of global expansion process. So, we've got one of the things that's been well known about an Earth that would expand is that it would produce what has been known as the orange peel effect, where the continental plates are they're actually torn apart as they increase in diameter. And so this is the orange peel effect. And so these can all be reconstructed, and then another effect is that because the Earth is more curved, as it expands, it tends to produce stress in compressional stress on the interior of the Earth. And so this produces all sorts of various where the plate is torn apart, and also produces lower areas in geosynclines in the Earth. So we've got various things about that. Again, quite a bit of detail about that. And this is quite interesting, because this is how it would actually affect the continental plates as the Earth actually expanded. And Cliff Ollier actually did quite a bit of work on this, and these are schematics after Cliff's basic concepts. So schematic vertical cross-sections of mountains from various continents. In each example, great escarpments parallel the coast and separate a high plateau from the coastal plain. Each continent also has a central depression, bounded by gentle rises to high plateaus, beyond which are abrupt outward-facing escarpments and coastal plains. So more, yeah. So this is basically everything must be the same. So, Chapter 17, Paradigm Shift in Understanding Extinction. A drop in sea level of 100 to 150 meters is a major physical consideration for the end Cretaceous. At the very least, this event caused a major loss of an extinction event. So this is actually trying to put the trying to see why the major extinction events happened and relate those to Earth expansion. Right, so I've gone through various phases. Chapter 18, a paradigm shift in paleobiogeography. So, plate tectonic reconstructions and proposed movements of continents do not correspond to the known or necessary migration routes and directions of biographical boundaries. Chapter 18, a paradigm shift in paleobiogeography. Plate tectonic reconstructions and proposed movements of continents do not correspond to the known or necessary migration routes and directions of biogeographical boundaries. So basically, this is saying that we find that various life in the past, we get up to we find that they don't actually match where things go. So biogeography is defined. Biogeography is defined as a study of the distribution of plant and animal species and ecosystems in geographic space and through geological time. These distributions are known to vary in a regular manner depending on their latitude, elevation, isolation, and habitat areas. Biogeography is also seen as an iterative field of inquiry that unites concepts and information. So we've got various diagrams here. Again, zoic life. We've got James Maxlow has plotted where the various life would be on his reconstructions, his global reconstructions at various times in the past. And there's a lot of detail there, which you would actually have to look at that in a great deal of detail. Right. So, where are we now? Chapter 19. A paradigm shift in metallurgy. Right, so major peaks in the abundance of metal deposits that formed or were preserved in convergent margin-based belts in the late Archean and metal deposits associated with either. Right, so this basically tells us where This is basically looking at where ancient metals such as lead, gold, tin, where they actually formed on the ancient earth, and from that we can actually see where they actually came from. Copper, silver, yeah. So we can see that they actually formed in a belt. Of course, knowing where they formed on an ancient earth will help us actually find new deposits of these, because on these models, where we know where the if we know exactly where they're joined, we might actually find they're on the other side. So, and similar idea with hydrocarbons for chapter 20, and that's a similar idea with hydrocarbons for chapter 20. Basically, if we know where they formed on our ancient earth, we can actually know where to look for them for today. So let's have a look. So yeah, so various models, and we look at fossils. We can look at all petroleum, natural gas reserves. We can see where they've actually formed. And this is a speculation on the yes, so speculating, part 3, speculating on the geologic rock record, and the quote here says, "The history of science demonstrates that the scientific truths of yesterday are often viewed as misconceptions, and conversely, that ideas rejected in the past may now be considered true." And that is actually from a scientific historian. So that a continental example. So this goes into detail again. Yeah, chapter 21, a continental example. Evidence suggests that West Australia and much of Australia has been largely intact since about 2.5 billion years ago. 2,500 million years ago. And that most subsequent activity has been, so rock record, and so final chapter 23, a paradigm shift in the cosmological implications. So so that goes right back to actually try and see what's actually been happening. And chapter 24 again covers that whole thing. Oh, he's actually quoted himself here. A paradigm shift in thinking. The biggest problem now facing geoscience today is accepting that plate tectonics may well be better suited to an increased radius Earth scenario. Which is very true. So that ends that. And then we have the various things at the end, and then appendix with even more detail at the end of how to actually do things. So it's quite an expensive book, so a university library would be a good place to actually get hold of it, I think, if you get a copy there. But it's got lots of detail in it about Earth expansion. I think basically every chapter, I would suggest that every chapter you could write a whole book about each chapter in here. So it gives you quite a bit of detail, but that's just a starting point. So, all right. Hope you enjoyed that review. All right, cheerio, bye.